All right, guys, I'm going to get started. We are going to continue to factor today. Again, we're going to take this kind of like a few days at a time. I try and show you a little bit of something new each day. But like I said, factoring is one of the most important things that I'm going to get to teach you all year. So please, please let me know if you are struggling with this because I will try and help you in any way that I can because it is so important that you know how to factor. And also, I told you guys yesterday that if you were to YouTube this or Google it, there's lots of different ways to teach you guys how to factor. I choose this way that we are doing this guess and check method because I really truly believe that you will remember it months and months to come. Other ways that I've taught in the past, I feel like I always had to reteach it when we got to it again in the future because you guys forgot what you were supposed to do. But this way, I feel like every number has a job and everybody remembers what everything is supposed to do. Okay. All right. But it does take some time to kind of get all the working pieces. All right. So I'm just reusing the notes from yesterday because we didn't do all of the problems. So I figured I'll just continue using these examples and we'll go from there. So guys, I'm going to start on the bottom with number 6 where we left off yesterday. And when we get to the back, I'm going to kind of skip around a little bit to certain problems, all right, to make sure that you see different things. All right, here we go. So guys, if our job is to factor, right now I am teaching you guys how to factor, for lack of a better word, a normal looking quadratic equation. You got your x squared, you got your x term, and you got your just number, right? A normal looking quadratic. That's what we're supposed to be factoring right now, okay? All right, so here we go. We always look for a greatest common factor first. So does an x squared, an x, or a 30 have anything in common? Number, variable? No. If they don't have a GCF, that means we are ready to break this up into pieces that multiply right away. So give yourself 2 parentheses, 2 factors to create. We said yesterday that we will use what we know about FOIL to help us do this. According to FOIL, we know whatever we put in the first 2 spots has to multiply to the first piece of that expression, x squared. And we agreed that we will always use an x and an x to get us that x squared and then help us get those x's that we need in the middle. All right, now, according to FOIL, we know whatever numbers we put in the last 2 spots, they always have to multiply to the last number in that expression, negative 30. So you are only allowed to put numbers that multiply to that negative 30 in these last 2 spots. Also, think about the clues. If we have to multiply to a negative number, we know we need opposite signs. We need a positive number and we need a negative number. Well, I like to give you guys options. What numbers could you put there? What numbers do you know multiply to 30? And that was it, guys. Those are the only 4 pairs of numbers that multiply to 30. So now if I know that these are just x's that I'll be using in my rainbows, then to get to that 1x there, which one of these pairs of numbers looks like they could get you a 1 when you go to combine them? 5 and 6 look like the only ones that could go to a 1. So I'm going to start guessing and checking them first. So throw a 5 and a 6 in. And again, because it's just x and x, it doesn't matter where you put the 5 or the 6. So somebody could put 6, 5, and we're still going to get the same answer. All right, let's see what our rainbows are telling us. 5 times x is 5x. X times 6 is 6x. If I need to multiply to that negative 30 and get these 2 rainbows to add up to that positive 1, we know they need to be opposite sign. So who has to be opposite? Who has to be positive and who has to be negative to get you that plus 1x in the middle? Well, I'd have to make the 5 negative and the 6 positive in order for them to add up to a 1x in the middle. So let's see if that works. If I need a negative 5x, I need a negative 5 there. If I need a positive 6x, I need a plus 6 there. And then let's double check to see if everything's doing its job. Did x times x get you an x squared? Yup. Did a negative 5 times a positive 6 get you a negative 30? Yup. And do your rainbows, negative 5x and positive 6x, add up to the 1x in the middle? Yeah, they do. So you know these are definitely the factors. These will multiply to equal that expression, and you're done. And like I said, if somebody put x plus 6 first, and x minus 5 second, they are just as correct. The order that you write the parentheses in does not matter. As long as one of them says x minus 5 and one of them says x plus 6, you are correct. All right, guys, give me a thumbs up if you remember that from yesterday and you're feeling pretty good still. Okay, let me just say this. I don't like to use the word easy because this is not going to be easy for everybody. But as far as these problems go, this is as easy as they'll ever be. When there's no number in front of x squared and it looks like that normal x squared x number quadratic expression, that's as easy as these problems are ever going to get. We saw yesterday that when there was a 5 in front of x squared, we had to work those rainbows a little bit harder to make sure everything was doing its job. So, like I said, that's as easy as these problems are ever going to be. All right, now let's go to the back, and it's where I'm going to skip around. On the back, I want to go to number 11 first. Let's go to number 11. Let's try to factor 11. So guys, if I had to factor this quadratic expression, right? I'm trying to break it up into pieces that multiply. We will always look for a GCF first. Does a 3x squared, a 13x, and a 12 have anything in common? A number, a variable, both? No. The biggest number that divides evenly into a 3, a 13, and a 12 is a 1, and we don't count 1. And then they don't all have a variable, so they couldn't have a variable in common. So since there's no GCF, that means we're going to factor this right now just the way it is. We're going to break it up into two pieces that multiply to equal it. All right, well, according to FOIL, whatever I put in the first two spots, they have to multiply to the first term, the 3x squared. We know we're going to use an x and an x, but now how am I going to get the 3? Well, guys, luckily, the only two whole numbers in the world that multiply to 3 are 3 and 1. So it's got to be a 3x and a 1x. If that had been a 4x squared, well, guys, a 4x squared, we could have used a 4x and a 1x, or a 2x and a 2x to create a 4x squared. So luckily, when this number only has one option, that makes it a little bit easier for us, right? You won't see the ones that have a 4x squared until maybe Monday. I don't bring those ones in, where we have to do really a lot of guessing and checking. All right, here we go. We know whatever numbers we put in the last two spots, they have to multiply to that positive 12. And then if I need my rainbows to get me those negative 13x's in the middle. So guys, if we're going to multiply to a positive 12, we know our signs have to be the same. I need two positive numbers, or I need two negative numbers to make this happen. Well, if I'm only allowed to use numbers that multiply to 12, what are my options? What numbers do I know multiply to 12? Those are them. So guys, this is why it's called the guess and check method. You just pick two factors, 3 and 4, 2 and 6, 1 and 12, and you start plugging them in and guessing and checking those rainbows. Can I give you guys a hint? Let me try and tell you this. This might cut down on some of the guessing and checking that you have to do. We already established that this problem does not have a GCF. So you don't want to write any factors that have a GCF. So let's say we were going to try the 3 and the 4 first, right? You definitely, don't write this down, you definitely don't want to put the 3 there and the 4 there. If I put the 3 here, this factor that I just wrote, this 3x3, they have a GCF of 3. And you don't want any of your factors to have a GCF. So I definitely don't want to put the 3 there, because then I'm creating a factor that has a GCF. So use that as kind of a hint where you can do less guessing and checking. So I know the 3 won't go there. So let's only try the 4 there and the 3 here, right? Because I'm not creating a GCF there. And let's see what my rainbows tell me. 4 times x is 4x. 3x times 3 is 9x. Could I get a 4x and a 9x to get me those negative 13x's in the middle? Guys, I think I can. I think 3 and 4 are going to work. All right, so let's see if I can get the signs to do what I need them to do. Well, how am I going to multiply to that positive and add up to that negative 13? They have to both be negative in order to make this work. All right, those will add up to a negative 13. So now this must be a minus 4 to get a negative 4x. And this must be a minus 3 to get a negative 9x. And let's double check that everything's doing its job. Does 3x times x get you 3x squared? Yup. Does a negative 4 times a negative 3 get you a positive 12? Yup. And do my rainbows, negative 4x and negative 9x, add up to the negative 13x's in the middle? Yeah, they do. So guys, we did it. We found them using the first pair of numbers we tried. Obviously, that's not always going to happen. We got lucky that the first two numbers that multiply to 12 that we tried happened to be the correct ones. All right, but again, let me give you another hint. Let's say you were going to try the 2 and the 6 first. Well, then I definitely wouldn't have put the 6 here, because a 3x and a 6 would have had a GCF. And we've already established there isn't a GCF. So you don't want to create a factor that has a GCF. All right. So again, hopefully you can use that to kind of cut down on some of your guessing and checking. So if you were going to try the 2 and the 6, I would have only put the 2 here and the 6 over there. But then you would have seen the rainbows don't work. All right. This is called guess and check for a reason. You guess and check the numbers until you find what works. All right, give me a thumbs up if that makes sense. Are we okay? Everybody okay? All right, perfect. All right, so again, this is what you would have typed in as your answer on the Delta Math. And guys, it doesn't matter. As long as one of your factors says 3x minus 4 and one of them says x minus 3, it doesn't matter the order in which you write these parentheses. Somebody might have written x minus 3 times 3x minus 4. Guys, that's still correct. That's still a correct answer, okay? All right, now I'm going to go to number 12. Let's go to number 12 next. All right, we have to factor it, right? We have to break it up into pieces that multiply. So we always look for a greatest common factor first. What does a 2x squared, a 1x, and a 15 have in common? Nothing other than a 1, right? And we don't count a 1. There's no number that divides evenly into all of them besides 1, and they don't all have a variable. So there's no GCF, which means we're going to factor it right away into two pieces that multiply to equal it, okay? All right, so we know whatever we put in the first two spots, they got to get us that 2x squared. So we know we're going to use an x and an x to get x squared, and luckily, there's only two numbers that multiply to 2, a 2 and a 1. So we're going to use a 2x and a 1x to get us that 2x squared. Everybody good? Okay. All right. Now, whatever numbers I put here and whatever numbers I put there, they have to multiply to that negative 15 at the end. So I'm only allowed to put numbers in those last two spots that multiply to negative 15. And remember, if I have to multiply to a negative, I need a positive number and a negative number. That's the only way I'll get this to work. All right. Well, give yourself some options. What numbers do you know multiply to 15? Well, guys, lucky for us, there aren't that many. There's only two pairs of numbers you could try. I'm going to try the 3 and the 5 first. So, guys, if I put the 3 here, and I can because they don't have a GCF, so that's safe. Even the 5 would have worked because it doesn't have a GCF with 2 either. All right, let's see what my rainbows do here. 3 times x is 3x. 2x times 5 is 10x. Guys, are you ever going to get a 3x and a 10x to go to a 1x in the middle? No. So before I say the 3 and the 5 don't work, switch them. Try the 5 over here and the 3 over there and see what your rainbows do now. All right, now if I try that, 5 times x is 5x. 2x times 3 is 6x. Could a 5x and a 6x go to a 1? Yeah, they could. Let's see if I can get the signs to do what I need them to do. I know I need a positive and a negative, right? So who has to be positive and who has to be negative to get to that 1x in the middle? Well, I would need a negative 5 and a positive 6 to get to that positive 1x in the middle. So let's try that. Let's put the negative here, and then let's put the plus there to get that plus 6x. And now let's see if everything's doing its job. Does 2x times x get you 2x squared? Yup. Does negative 5 times positive 3 get you negative 15? Yes, it does. And then do your rainbows, negative 5x and positive 6x, get you the 1x in the middle? Absolutely. So these are definitely the factors. These are definitely going to multiply to equal that expression. All right, guys, thumbs up if that felt okay. Everybody good? All right, so again, like I said, when there's a number in front of x squared, we definitely have to work those rainbows a little bit harder to get that middle term, but that you just keep guessing and checking until you get there. All right, now I'm going to jump back to number 7. I want to show you guys something new for today. All right, let's jump back up to number 7. So guys, remember, right now I am teaching you how to factor a quadratic expression, right? That x squared term, that x, and that number. So when you look at number 7, a red flag should go off in your mind like, wait a minute, something don't feel right. This is not a quadratic expression. This is a degree 3 expression. The highest exponent on a variable is 3. So right away, you should be like, wait, this is not okay. So hopefully that will remind you, like when something doesn't look normal, then definitely don't forget to look for a GCF, because maybe by taking a GCF out, you can get this to look a little bit more normal. All right, so let's look for a greatest common factor. What does an x to the third, a 3x squared, and an 18x all have in common? Well, guys, they don't have a number in common. There's no number that will divide evenly into a 1, a 3, and an 18 other than 1, but we don't count 1. But they definitely all have variables. He's got 3 x's, he's got 2, and he's got 1. So the greatest number of x's that they all have is that 1x. So we can take that 1x as the GCF, and we're going to factor it out. All right, so now we're going to take x out, and we're going to create a new expression to get back to the original. So if I take an x out of all of those pieces, x times what is going to get me back to it? All right, well, x times what gets me back to x to the third. took one of his x's out, 2 will be left. So x squared. X times what gets me back to a 3x squared? A 3x, right? Because I took one of his x's away. And then x times what will get me back to a negative 18x? A negative 18, because I took that one x that he had out. So now, if you look, this looks like we're back to a normal quadratic expression, right? So what you do now that you've taken the GCF out, you're going to bring the GCF down because he's part of your answer. Now you're going to treat this like a brand new factoring problem, and you're going to try and factor it into 2 more pieces. Now you're going to try and find 2 factors that multiply to this, all right? All right, well, again, just start like it's a new problem. I know whatever I put here and whatever I put here has to multiply to that 1x squared. And we know we're going to use an x and an x to get that. All right, and then according to FOIL, I know whatever I put in the last 2 spots has to multiply to that negative 18. So I'm only allowed to put numbers in those last 2 spots that multiply to negative 18. And I know if I have to multiply to a negative, I need a positive and a negative number to do this. So I'll need opposite signs. Well, guys, give yourself some options. What numbers do you know multiply to 18? That's it. Those are the only numbers that we could possibly use in this problem. And since it's just an x and an x, it shouldn't matter where they go. Like I don't have a 2 in front of one of these x's or a 5 or a 3, so it shouldn't matter. So guys, look at these numbers. Which ones look like they could get you that 3x in the middle? I think the 3 and the 6. So let's try them first. 3 and 6 in any order. Let's see what our rainbows are telling us. 3 times x is 3x. X times 6 is 6x. Can I make a 3x and a 6x go to a positive 3x when I need them to be different signs? Yeah, I think I can. So how do I make a 3x and a 6x go to a positive 3x? I'll need a negative 3x and a positive 6x in order to make this work. All right, well, if that's true, then this is going to have to be minus to get those negative 3x's. And then this is going to have to be plus to get those plus 6x's. And let's double check to see if everything's doing its job. Is an x times an x going to get you x squared? Uh-huh. Is a negative 3 times a positive 6 going to get you a negative 18? Yup. And are your rainbows a negative 3x and a positive 6x going to get you the 3x's in the middle? Yeah, they are. So these are definitely the factors. So normally students are okay with this, but the biggest mistake they make is they forget to write the GCF as part of the answer. A lot of students will just circle this as the answer. But remember, you need to make sure that you can multiply back to the very original problem. And we will not be able to multiply back to the original without that GCF. So please don't forget that your GCF is part of your answer. And then you would type all of that into your Delta Math answer box. And again, it doesn't matter the order in which you write it. If somebody wrote x plus 6 first and x minus 3 second, that's perfectly fine. Okay? How does everybody feel about that one? So again, that's a case where we had to look for a GCF first. You had to take that GCF out before you went on to that normal factoring step. Okay? All right, here we go. Let's try number 8. Are you okay? What's the matter? Small ball. Oh, all right. So number 8, same thing, right? It looks like a normal quadratic expression, right? So maybe this one doesn't raise a red flag as much, but we have to look for a GCF. That's how we start every single factoring problem. What does a 2x squared, a 16x, and a 14 have in common? Guys, they do have a GCF. They have a number 2 that will divide evenly into all of them. So we definitely want to factor that 2 out because what it should do is make it easier to factor. So let's take the 2 out and see what expression is left. It'll leave you with easier, smaller numbers to work with. All right, so 2 times what gets back to the 2x squared? I'll need an x squared. 2 times what gets you back to the negative 16x? A negative 8x. And then 2 times what gets you back to 14? A positive 7. All right, and now you bring the GCF down. You treat this like a brand new problem, and let's see if we can factor it again into 2 more pieces. All right, well, according to FOIL, whatever I put in the first 2 spots better get me the x squared, and we're going to use an x and an x to do that. All right, whatever I put in the last 2 spots, I know has to multiply to that last number, positive 7. So guys, remember, if we're going to multiply to a positive, our signs have to be the same. So either a plus plus or a minus minus could make this work. All right, well, if I'm only allowed to put numbers that multiply to 7, what options do I have? Well, guys, not a lot. There's only two numbers that multiply to 7, 1 and 7. And since there's no number in front of these x's, it would not matter where I put them. So throw them in, 1 and 7. And let's see what my rainbows get me. 1 times x is 1x. X times 7 is 7x. Could I get a 1 and a 7 to go to an 8? Yeah. But guys, I got to go to a negative 8. So that means I need them to both be negative. All right, so that means I would need a minus here, and I would need a minus there to make this work. Let's see if everything does its job. Does an x times x get you an x squared? Yup. Does a negative 1 times a negative 7 get you a positive 7? Yup. And do my rainbows, negative 1x and negative 7x's, add up to the negative 8x's in the middle? Yeah, they do. So this works. These are our factors. So this is what you would type into Delta Math as your answer. Now, guys, let me pause for 1 second. If you didn't take the GCF of 2 out, I just want to warn you that you would be able to factor it. You could use a 2x and a 1x and then put numbers that multiply to 14. I'm telling you right now, it will factor if you forgot to do it. The problem is the directions at this worksheet said factor completely. If you didn't take the GCF out in the beginning, then one of these parentheses that you wrote would have a GCF in it. One of those parentheses would have a common factor, and you'd have to factor it out of one of those parentheses at the end of the problem. I'm trying to get you to avoid having to do that. Always take the GCF out right from the get-go. All right, I'm going to ask you guys to try number 9, and then I'm going to give you a head start, and then we're going to stop after that one. So you guys try number 9. Can I just give you a hint? It definitely has a GCF, and the GCF is a number and a variable. All right, you guys get a head start. You guys try that one, and then I'll catch up. Let me check the attendance while you guys do it. All right, we got Jack, Brody, AJ, Elijah, Yandil, Gianna, Paige, Attilio, Mariah, Dory, Elijah, Justin, Lily, Rodrigo, Logan, Anthony, Adrian, Connor, Osman, Rivki, Matt, and Brandon. All right, I don't have Floor. I don't have Donaldo. No Kayla or Ian. And no Pessy. Rivki, are you there, sweetie?
Yes.
Is Pessy okay? Is she sick? I don't mean to put her on the spot. I hope this is okay, just because I haven't seen her in a few days.
She's fine.
Okay, all right, never mind. No, thank you. Thank you, sorry. So guys, if you look at mine, I'm saying that 3x is your GCF. So you definitely want to factor the 3x out and see what's left. And then you can try factoring your new expression again. And again, by taking the GCF out, it should only leave what's left easier to factor. Right, I'm trying to get the last two spots to multiply to that -4. So remember, to multiply to a negative, you're going to need different signs. One positive, one negative. The only numbers I know that multiply to 4 are 1 and 4 and 2 and 2. So you just pick your favorite and start guessing and checking until you get those rainbows to do what you need them to do. Looks like I can get the 1 and the 4 to work. I would need a positive 1x and a negative 4x to get that negative 3x in the middle. So then I would need a plus and a minus. And those are your factors. Okay. All right, give me a thumbs up if you're feeling pretty good right now. Everybody hanging in? You're okay? Okay, like I said, I give you guys a lot of credit. I know, like, this takes some time to get used to, and it's a little tedious in checking everything, but I'm telling you, this way, you should, months from now, when I say to you guys, hey, factor that for me, you're going to know what you need everything to do. This and this got to get me him, that and that got to get me that, and my rainbows will get me the middle. I'm telling you, you will remember what everything needs to do in the future. All right, so again, the only thing I tried to throw new at you today was I tried to show you a few that had this GCF that had to come out, okay? All right, so guys, I did create a homework for you on Delta Math again. It's 10 questions. Some of them are easier than others, so just take your time. I didn't make it due until Monday night. So I gave everybody the entire weekend, and even Monday after school, just God forbid you have a busy weekend with work or other commitments. I gave you the entire weekend and Monday after school to get those 10 problems done. But guys, just remember, on Monday when we factor again, I'm probably going to give you another homework on Monday. So if you can get it done today or over the weekend, I think that would be best. But I did give you Monday as a cushion in case anybody needed it, okay? All right, looks like I have